Greetings, a little video help to help you solve these problems, in particular the speeding on I-5 part 1. I'll help you get them set up and then I'll let you take them home and actually solve them, okay? So we've got a distribution of passenger vehicle speeds traveling on Interstate 5, I-5 in California is nearly normal with a mean of 72.6 miles per hour and a standard deviation of 4.78 miles per hour. What percentage of passenger vehicles travel slower than 80 miles per hour? Please round your answer to 2 decimal places. Okay, as usual when we're working with the normal distribution, for a matter of fact, any distribution you're working with, you should draw a picture that describes the situation first. So let's do that. So this is the distribution of traveling speeds on I-5. And if you've ever driven on I-5, I think that means a little low. Just saying. Okay, so X is equal to the speed on I-5. So our horizontal axis represents that value, and the vertical axis, of course, that's the frequency, or actually the density in this case. Okay, so we know the mean here is at 72.6 miles per hour. And we know that the standard deviation, sigma, is at 4.78 miles per hour. Okay, and what they want to know is what percent of the passengers travel slower than 80 miles per hour. Okay, so let's see, 76, roughly 77 would be about one standard deviation to be about there. So 80 is going to be roughly about in that neck of the woods, right about there. Okay, now slower than, so what does that mean? Which part of this distribution are we going to shade? We're going to shade the lower tail, this part down here, right? And so what that means is that I'm going from negative E99, which is negative infinity in calculator parlance, up to 80. So my left endpoint is going to be negative E99, my right endpoint is going to be 80, my mean is 72.6, my standard deviation is 4.78. Okay, hopefully that gets you going. I'll let you take it from there onto the calculator. Let's take a look at the next part for this. So on part B, it says what percent of passenger vehicles travel between 60 and 80 miles per hour? Round to 2 decimal places. Be sure when you input these into the computer system that you round off correctly. That's always a drag to get it wrong because you rounded off incorrectly. All right, let's go ahead. Again, draw ourselves a picture that represents this situation. Normal distribution, again, X is equal to speed on the I-5. Again, we're centered at 72.6. And our standard deviation is equal to 4.78. Okay, so between 60 miles an hour and 80 miles an hour, so we saw 80 was roughly about that neck of the woods, right about there. So 60, let's see, that's going to be down over about here-ish, isn't it, right? Because we figure we're going about 5 miles per hour roughly is our standard deviation, so drop it down roughly 10-ish, you know, and that's going to be about 60, okay? All right, so they want us to calculate the area between those 2 points this time. So this region right here is going to represent the proportion of vehicles that drive between 60 and 80 miles per hour on the I-5, okay? So that means your left end point is going to be 60, your right end point is going to be 80, your mean is going to be 72.6, and your standard deviation is going to be 4.78. Okay, again, I'll let you take that home and just help you get it set up, and let's go take a look at the next one. So in part C here, now what they would like us to do is how fast do the fastest 5% of passenger vehicles travel in miles per hour? Please round your answer to 2 decimal places. Okay, so one more time with the drawing. You're going to get to draw it 4 times in this particular problem. That's awesome. So there's X again, which is our speed traveled on the I-5. Our mean is at 72.6. Our standard deviation is at 4.78. Okay, so how fast do the fastest 5% of the passenger vehicles travel? So now notice that this time what they gave us is they gave us an area. And the area they gave us was 5%. In other words, they want the top 5%. So that red shaded region right there is 5%. Well, now notice, because of the way our calculators calculate this, we're going to have to calculate what? Well, we'll do it in green here. We're going to have to give the calculator the complement of that, or the 95%. Because remember that the calculator sums it from the left-hand side. In other words, it needs its area from the left-hand side. So in order to be able to do this, notice I'm given an area, I want to know a position, so I need to know that position on the axis right there. And so I'm going to use inverse norm. I'm going to let you fill in what you got to put into the actual command, okay? But the idea being that they gave me an area, they want to know a position, all right? Okay, take it home from there. If you have any questions on that, please don't be shy about posting the Q&A form. All right, let's take a look at the next one here. So given the next one, we have the speed limit on this stretch of I-5 is 70 miles per hour. Approximately what percentage of the passenger vehicles travel above the speed limit on this stretch of I-5? Round your answer to 2 decimal places. I would say 100%, but I know there's some old folks out there that drive, older than me, shall we say, that drive slower than 70 miles per hour. Okay, so mu is equal again to 72.6. This is MPH. I should probably put that down every time. Sigma is equal to 4.78 miles per hour. Okay, so the speed limit is 70 miles per hour. So let's see, people are above average here, aren't they? They're driving above that speed. But let's see, that's going to be basically 2 units down from there. So about there-ish is where the standard deviation is. So I would say roughly, if I had to guess, I would say right about there is 70 miles per hour on my axis, okay? So that means what I need is I want to know approximately what percentage of passenger vehicles travel above the speed limit. So I got to decide which side to shade here. So travel above the speed limit, that's going to be this region here, isn't it? Whereas this red hashed area here is the folks that drive above it. Okay, so notice that you're starting at 70 miles per hour, excuse me, and you're going to go out to E99, which is, infinity in the calculator's parlance. So your left-hand endpoint is going to be 70, your right endpoint is going to be E99, your mean and your standard deviation has been through the last 3 problems. Okay, so hopefully that gets you kick-started. If you need further help with this, do not be shy about posting the Q&A form, or you can message me directly.